Afternoon, guys. So it is now Wednesday, and I'm hoping that you guys are actually getting to this early, since I'm actually going to have it posted before you guys even get to school today. Um, but I'm, anyways, I'm hoping you guys will get to your notes and get them done early, so you guys can have the rest of the night to just relax. Remember, you need to be doing your steps, writing steps, and or I guess I should say. Also um, your steps or your uh, summary of what exactly we're learning. So today we're going to be covering solving rational equations. Um, and there's really actually not a whole lot to this. It's more or less just going to be getting rid of a denominator is really all it's going to be. But it shouldn't be all that hard for you, and hopefully we can get this done and not have any trouble with it. If we do, then we do, and um, hopefully we can get that taken care of. Make sure you write down any questions that you may or may not have for me, and I will go ahead and try to help you out with that when you guys come into class. Anyways, so what we're doing today again is solving rational equations, and so let's go ahead and get at it. All right, so we have a fraction one or a rational expression 1 over x equals 1 over 6 minus x, and we are looking to, when we do this, all we're really looking to do is we're just looking to get rid of the denominator and actually make this just a regular equation, not with fractions or rational expressions in it. So what we're going to do is we're going to find what we're going to find the common denominator. Okay, so I'm going to look for the LCD, least common denominator, and in this case, the only difference between this and what we would do if we're actually finding a common denominator. Okay, the easiest way to find a common denominator is if these two don't have a common factor that's in common, then I'm just going to multiply the two together. So what I'm saying by that is 6 minus x, it can't be factored, and x does not have a common factor with 6 minus x. So since that's the case, it means my common denominator is just going to be x times 6 minus x. Now in doing this, what we're going to do is we're going to end up taking this and we're going to multiply both sides by x times 6 minus x. Okay, now I'm not multiplying top and bottom, I'm multiplying just both sides. So this is actually what you're doing. So now I have x times 6 minus x times over 1 times 1 over x. So in doing that, now I can go ahead and, because it's multiplication, I can cancel the x's. And the same idea here, since it's multiplication, I can cross cancel, so I can cancel the 6 minus x's. This is going to leave me with 6 minus x times 1 equals 1 times x. And now I'm going to be able to solve. This is 6 minus x equals x. I'm going to add x to both sides. I get 6 equals 2x. Divide by 2, and I get x equals 3. Okay? And if you want to check it, you can. 1 over 3 equals 1 over 6 minus 3. Well, 6 minus 3 is 3. So this would be true. Okay? So now we get to number 2. And we're going to actually just do the exact same thing. Now in this case, this one actually happens to be a little bit easier. Just in the fact that x minus 1 is already their common denominator. So my LCD then is x minus 1. So I'm going to multiply both sides by x minus 1. Put them over 1, multiply straight across. Okay, so now we can do our canceling. So I can cancel x minus 1 and I can cancel x minus 1. This leaves me with x squared equals, and this is going to be 1. And now I'm going to take the square root of both sides. Anytime, this is very important to remember, anytime you have a square or a cube or a fourth root or a fifth root, you always take that radical. Okay, so in this case, this is square root. If I was taking the third root, it would be the radical with a 3. This is the third root. This is the fourth root. This is the fifth root. Okay, now with the squares, the other thing you always have to remember then is with a square root, you're always going to have to take the plus and the minus. You're not going to be doing just one of them. If you think of the square root of 8 squared, well, 8 squared is 64. What's the square root of 64? Well, it's positive 8, but it's also negative 8. So that means that every time I take the square root like this, it's always going to be x equals plus or minus 1. Okay? Now, and actually I forgot to do something. So let's go back here. Now we have to deal, and actually I'll do it in a different color. We need to deal with our excluded values. Okay? So I have to set x equal to 0 and x, excuse me. Let me fix that. And 6 minus x equals 0. So now I have to solve this one, so I'm going to subtract 6 to both sides, and I get negative x equals negative 6, divide by negative 1, and I get x equals 6, which tells me that my excluded values then are x equals 0 and x equals 6. Okay, now my answer was x equals 3. Now, on example number 2, this is actually going to be a perfect example of what I'm referring to here, and why we have to check the excluded values. Okay, so let me go ahead and fix this real quick. Put it on orange. Okay, so we got x equals plus or minus 1. Now let's do my excluded values. Okay, and since they're both the same, I only have to set one of them equal to 0 because it's going to be the same either way. I'm going to add 1 to both sides, and I get x equals 1, which means that x cannot equal 1. So that means that my answer then is going to be only x equals negative 1. And I'm going to show you why right now. Okay, if I put in 1, that's 1 squared over 1 minus 1 equals 1 over 1 minus 1. This is 1 over 0 equals 1 over 0. Well, 1 over 0 is undefined. Okay. If I try negative 1, that's negative 1 squared over negative 1 minus 1 equals 1 over 1 negative 1 minus 1. This is 1 over negative 2 equals 1 over negative 2. And this one checks. So that is why my answer is just x equals negative 1 with a excluded value of x equals 1. Okay? So this is where it's very important to see the excluded values and their importance in dealing with rational expressions. If you guys have any questions, make sure you ask me. We'll be doing some work with this today, and we'll actually get that taken care of right away. So I will talk to you guys tomorrow, I guess, and have a great night.